Hi, in this presentation I'll be deriving Einstein's E equals mc², his special theory of relativity. Now I'll begin by talking about the change in energy defined as F dx. Now F can be thought of as dp dt. I could rearrange that as dp dx dt, and this is really the definition of velocity, so it's v dp. So dE is equal to v dp. Momentum, well, dp is equal to m dv plus v dm. I could replace this with this. So I end up with dE as mv dv plus v squared dm. Okay, so now I'll talk about relativistic mass increase. Now I'll differentiate m with respect to v. Now this can be thought of as that rest mass multiplied by 1 minus v squared on c squared to the negative a half. And I'll use the chain rule to try to differentiate this. So that'll become a constant there, rest mass. Now differentiating the brackets, I end up with negative a half, 1 minus v squared on c squared. Negative a half minus 1 is negative 3 on 2, and I'll differentiate inside the brackets to give me negative 2v on c squared. Now as it turns out, a minus and a minus gives me a plus, and negative a half times 2 negative gives me just positive 1. So this can be further simplified as m, that rest mass, v over c squared, 1 minus v squared on c squared, negative 3 on 2. However, I could expand this out so that it looks like this. One minus v squared on c squared, negative a half multiplied by 1 minus v squared on c squared, negative 1. And the thing is that this multiplied by this looks exactly the same as this. And so I could replace all of that with mv on c squared, 1 minus v squared on c squared minus 1. I could express this in a different way. The number 1 can be thought of as c squared on c squared minus v squared on c squared. And that'll give me mv on c squared minus v squared on c squared, power of negative 1. I could get the reciprocal of this and multiply. It would look something like this. And in effect, this would cancel out with this, all equaling dm dv. Now, as it turns out, multiplying both sides by c² minus v², multiplying both sides by dv, I end up with c² minus v². I end up with c² dm minus v² dm equaling mv dv. And so I could replace this with all of this to give me dE c² dm minus v² dm plus v² dm. Now these two quantities will cancel out. I end up with dE is equal to c² dm. Well, now I'll integrate both sides. E initial, E final, M initial, M final. And I'll end up with E final, E initial, integrating there with respect to M, keeping in mind that c² is a constant, M final, M initial. But that'll give me E final minus E initial is equal to M final minus M initial c². But what that really means is the change in energy is equal to the change in mass multiplied by the speed of light squared. And that is E equals mc².